Hey guys, how's it going? I'm Jake with SendCutSend. Today we're in my shop, the Holland built shop. We're going to be working on my Hayabusa powered trophy truck. We're going to be installing this brake pedal using the cardboard to CAD. We're going to send that CAD to SendCutSend, get our laser cut parts back, put it in the truck. Let's get into it. So first thing, we have to figure out where we want this brake pedal in the car. I'm gonna have a friend here, he's gonna be holding the brake pedal. We're gonna be looking at just the vertical up and down of where the pedal's gonna be. I'm gonna want it right in the ball of my foot here. And once we have that pedal where we want it, I'm gonna go ahead and just mark it on the chassis right here on the height. We can go ahead and take that pedal out of there now. The next step is I'm gonna transfer that mark onto the other side to get a nice level field that we're gonna be making the cardboard template. So we got 17 inches. I'm gonna go ahead and mark that 17 inches here. Perfect. Next part, we're gonna be making the cardboard template that'll fit that. So we're gonna start by figuring out where the holes are that we need to have inside the sheet metal template to transfer onto our cardboard. So we're gonna come up here with a level and we're gonna hold it somewhat similar to where we just made those marks where the pedal height is. And since this bar is gonna be kind of kicked out on the bottom and it's on an angle, we gotta kind of figure out where this location is in comparison to this location. So I'm gonna come in here, I'm gonna make a measurement, it's 3 inches. So we're gonna come down here to the handy dandy whiteboard, draw our 2 holes. We're making a measurement from here to here. This measurement is 3 inches. The last measurement we need is we can take a center to center on this direction. So we're gonna come back to our hole. We can make a mark on our, kind of line it up. And the cardboard template's about getting close right now. And then we're gonna come back in with our CAD work and be a little bit more finer. Transfer these measurements down here off of our level. I got about 11 3/4. So now we have these. We're gonna go ahead and take these measurements and transfer it to the cardboard. Get that cardboard template in here, do any trimming that we need to do, then we'll go to the CAD. So now we're gonna be taking those measurements that we just took and bring it down to the cardboard. So we're gonna start off, we need a square, because with the measurements that we just took are nice square measurements. I'm gonna be using 2 different Sharpies to make it a little bit clearer. The 2 measurements that we took were 11 3/4 and from center to center of the tubes on the horizontal axis. And then we're gonna be taking a 3-inch measurement up to the bottom or the tangential part of that tube and marking that location. Lastly, we just need to have a little bit of space around these. So we're gonna add a little bit of space around them for the template so that we kind of know we want about 1/3 of engagement on both sides, here and here. And we're gonna cut this template out, take it, put it in the car, and then we'll make any adjustments that we need before we take it to the CAD. So now that we got the cardboard cut out, we're gonna go ahead and put that in the car and check those measurements that we just took. So we're gonna line those measurements up with those lines that we drew earlier when we had the brake pedal up. Now we can see that we have a nice, decent tight fit on both sides. That means that our measurements are close. And since we're happy with those measurements, we're gonna take those measurements now, go to CAD, and draw them up. So we have our cardboard design. We know where our 2 locations are that fit pretty well. We need to take this and get it into the computer so that we can start either doing a paper model or maybe a harder template model that we can justify. Then we'll go to SendCutSend. So now that we have those 2 located, what we wanna do next is we wanna measure the hole pattern of the bolts for our brake pedal, as long as any clearances that we're gonna need in the bottom of the part. We're gonna apply those to this design. So I spent some time. Now I have a hole pattern that matches my brake pedal and a slot that allows the brake pedal to go through the entire assembly. So if we look here, I have a hole pattern that's every 1/2 inch. This is gonna allow us, since it's a 4-hole pattern, it's gonna allow us to have 3 different orientations and an inch difference in front to back orientation. This slot also is just fitted to the brake pedal that we're gonna be using. So then typically what we're gonna do is we're gonna finish this sketch We're gonna create a solid off of it. We're gonna roll this up. I'm gonna be making this out of 135,000 steel. So I'm gonna go ahead and use that as my dimension. Sorry, my body's selected. We're gonna hide that sketch. So now you can kind of see how this part's starting to form in a 3D sense. So we have these holes again in there in their pattern, the brake pedal clearance, as long as the two tubes that we're gonna be trying to tie into. Now, what we're gonna do is the next step is we're gonna create a DXF. If you're gonna be using a paper doll model, now is the time that what you can do is just create a sketch of this or a drawing off of your CAD software, create a one-to-one drawing, print that out, and then you can apply that paper doll onto a piece of cardboard or a piece of wood, and then transfer that template onto the wood or the cardboard and use that as your template. For me, I'm gonna be using a CO2 laser that I have in my shop. I'm gonna be cutting out some thin wood that I got from a box store to use as the template. So in order to do that, we're gonna come back in. I'm gonna create a sketch on this and finish it. What this sketch does is it creates an outline of what we just made. And so that's what SendCutSend can use from us, and that's also what a CO2 laser will use. So in this software that I'm using, I simply just right-click, save as a DXF. I save it to the flash drive. So now that we have that DXF and saved to the flash drive, we're gonna take that to my CO2 laser, cut this out, and do our first fit and figure out where that pedal needs to be front to back. So we're back at the car now. I got the brake pedal and that freshly cut wood part that we just did on my CO2 laser. I'm gonna check the fit of this template before we get it in the car, if we have any interference. We're gonna go ahead and put it in here. And we do have a little bit of interference right here. There's a little pin that holds the pedal. So we're gonna have to make a little bit of a modification. We'll probably just, we'll take a little piece out like that on each side, get this pedal fitting in there nicely. And then we're gonna check it all in the car, figure out that back and forth pedal position, and then we'll go to the final design. So we do have a little bit more interference here. I didn't take into account for the bottom mounts of the master cylinders, but I think right now we can still use this template. We're gonna get it in there. What we're looking for is just knowing which hole pattern that we're gonna be using, that I can get rid of the rest of the holes, and then we'll add in the clearance and stuff for those master cylinder bolt holes. So we're gonna take this, we'll take the pedal back out right now. A lot of times, as we check this fit, a lot of times we have a little bit of interference right here also. So a little bit on that weld joint. So let's take our knife real quick, knock off that corner. So this is all stuff that as we do this, we're gonna make sure that in our final design, a lot of this stuff is taken care of. Let's double check that part one more time. There we go. Now we're fitting nicely. So a lot of these little tight joints right here, since this bar is coming at an angle, it's a little bit extra tight right here. What I like to do is leave those corners really tight. And then when we get that laser cut part in metal, we'll do that final trimming in the metal so we have a nice tight joint and we don't have to have as much filler. The next step of this though is now that we kind of have this in here and it's held in place, so I like to use a hot glue gun, and we're gonna kind of hot glue some gussets in here so that this piece is kind of held in a manner that we want. We'll put the brake pedal in there, and then we're gonna figure out that location. So we're gonna kind of hold this up in here. We'll squeeze some hot glue. We're gonna go ahead and let that glue cure up a little bit, add some tape to reinforce the joints, and then we'll get it in the car, figure out where that brake pedal needs to be. So the design is in, it's reinforced for us to check that back and front. I'm gonna have my buddy here. We're gonna install the brake pedal as I'm sitting in the car. There we go. We're gonna start at the front hole and we'll just kind of work back and forth and just kind of see what's right. Go ahead and move that back a little bit, Drew. Yeah, that feels about right. So now that we have the holes kind of determined, we're gonna go ahead and mark which ones so we don't forget. And let's mark these ones too here in the front, make sure. There we go. Perfect. Okay, so now we're going to go back to the CAD. We're going to take those hole patterns and all the little interferences that we learned, and we're going to start working on that final design so that we can do one last template, check the fit, get those DXFs to SendCutSend, and get some metal parts started. So I spent a bunch of time on this design, drank some whiskey. I think we're all good to go now. So I want to talk about a couple specific things that I did with this design that are important to think about. Firstly, typically with hole sizes for bolts, what I'm going to be doing on that is that I either take the bolt dimension or I take the hole size of the part that I'm using. And in this case, since we're going to be mounting a brake pedal into this spot, I use the same exact hole size that is actually on the brake pedal itself. And so that, as you can see here, this is a 340 thousandths diameter hole. So my holes are going to be 340 thousandths in my part. That's going to be a 5/16 bolt most likely is what I'm going to be using. So we have plenty of clearance. It doesn't have to be a tight fit. It's a nice loose fit. It's going to be fine. Secondly, I used a tab and slot design in this part. That's for a couple different reasons, but mostly it's for the fitment and making it a little bit easier and less clamps when it comes to welding. That's also going to help create a 90-degree joint in this corner to make sure that my brake pedal pad is going to be sitting nice and flat in the car, as this one right here registers up against the tube, and then this joint right here, it ties those two together. But I do want to talk about the tab and slot design in a little bit more detail, specifically with the tolerances that are on the slots in comparison to the tabs. So I went on to SendCutSend's website. I decided that I'm going to use 104 thousandths thickness steel. In my experience, that steel comes pretty close to size, but what we want to do is we want to have a little bit of error when it comes to the cut thickness for SendCutSend and that part thickness from the sheet metal. And so the rule of thumb that SendCutSend tends to use is to give 10 thousandths of an inch clearance around your part in order to make sure that you that is a slip joint. So if we come back to the part here and we zoom in, we can see that on each side of that part we have 5 thousandths of an inch on that. And then I also rolled this edge to a half circle. What that does is, in this part, it's not going to be seen as much stress as in the front, but that's a good overall design method to make sure that those square corners sometimes will create cracking here, or it creates a weak joint. So if I'm trying to slide this in and there's any hesitation, I can also bend right here. So this will strengthen up this corner, and then what we're going to do is just weld this seam through here. Another thing that I want to talk about is that with that tab and slot, I typically make my tab about 20 to 30 thousandths of an inch taller than my thickness of my material. And what that does is it allows me to have filler material, so I don't have to feed filler while I'm TIG welding. It's already there. I can just flow those two pieces of metal together and create that fusion weld. It makes it a little bit easier. So you can see here I have 135 thousandths thick part, and you can see how that's a little bit proud of the top of the part. This creates for an easier joint. You can also see the same thickness here where I have a little bit of a proud stick out here. Same design on the side here. This little cutout right here creates a little bit of an area in which my master cylinders can slide into the front, because this is a reverse mount pedal. The master cylinders will bolt on right here, creates a little bit more of a clearance. This was an area in which we had interference on our last prototype design, so we cleared that area out. I also created a pocket in which is a little bit wider right here. That's for the design for those pins to slide through when we're installing it, and it's only for the installation phase. Next, what I ended up doing is I added a bunch of holes for later on in the design, and that's for having sheet metal on the foot box. That's for the finalizing of this area. And I added 1/8 inch holes. This will be for like some 1/8 inch rivets so we can tie the foot box and that sheet metal back to this pedal mount. So you can see here, I ended up just adding straight eighth of an inch holes. SendCutSend typically recommends about 5/1000 of an inch tolerance when you're doing that kind of stuff for hole sizes. With these will be easy holes for me to chase with an 1/8 inch drill later on. And so I'm not too worried about tolerances on these. I'll fit them to the rivets that I'll be using later. If you are gonna be using like specific tight tolerance holes, it is important to make sure that you give that 5/1000 tolerance over, say, a tight fit hole on a bolt. So look up the sizing chart for a bolt, look up tight fitting hole size for a bolt, and then add about 5/1000 of an inch to that to make sure that your actual bolt's gonna slip through that hole, unless you can chase it with a drill and you're okay with that. But additional kind of fitment's gonna be required if you kind of play that tight tolerance game. So that's it for this part. We're gonna go ahead and do the same thing that we did with the last template. We're gonna go ahead and create DXFs of all these parts. I'm gonna go to my CO2 laser, cut these parts out of that same wood. We're gonna install it one last time, double check everything's good. Then if everything is good, we don't need to make any changes. We'll send these DXFs out to SendCutSend. They will cut them out for us. We'll get them back and we'll see how they fit. What you can do is if you don't have a CO2 laser, you can do the same exact method, create a 1-to-1 drawing of these, translate them either to wood, some thin plywood, or cardboard, cut them out, and do that same fitment that I'm about to do. Because all we're talking about right now is making sure that clearance issues and stuff and that the overall size of the parts are gonna work and the gussets are gonna work in the design. See you in the shop. So we have the final template in the car. I'm pretty happy with the design. We have the tab and slot design in the front for this backbone piece. That's gonna tie this area back together that we had to cut out for the clearance for the brake pedal. We have this bent part here. With the template, I ended up cutting it, bending it in there and re-gluing it back together. We're gonna trust that SendCutSend gets this right for us. We have these extra holes here that we've added. We've added it over here also. That's gonna be for this foot box that we end up building in later on in the design. I think we're ready to go ahead and send these DXFs to SendCutSend, get our laser cut parts and get it welded in. So we got all the laser cut steel parts back from SendCutSend. They're exactly like what we sent them. We're gonna get this brake pedal installed onto this plate, make sure all the bolt pattern and stuff fits like we want it to. Then we're gonna install this on the vehicle next. Everything looks really good. We're gonna use non-nylocks right now because we're gonna actually leave this brake pedal in there, keep everything nice and flat as we weld and tack everything together. And then in the final assembly, we'll put grade 8 bolts, nylock nuts in there and get it all tightened up and we'll be ready for the next step. Okay, so the brake pedal is now mounted on here. We're gonna leave this on here with its bolts nice and tight. This is gonna keep this thing nice and flat. It keeps the holes where we want them. Right now, this little web right here in this design is the weak spot. And so since we don't have the front tied in right here with that tab and slot design quite yet, these holes in this brake pedal is gonna keep this thing from getting twisted in a couple different ways as we get it kind of tuned into this chassis. So we're gonna go ahead, let's bring it in here. We're gonna bring it and get it down to our lines. So we can see right away, this weld right here, we have a little bit of interference right here. One big thing that we have to remember is that when we do a cardboard template or a wood template, they're much more forgiving than an actual metal part. And so most likely our wood or cardboard template folded right here and I actually didn't see that interference. So we're gonna just go ahead and mark that. We're just gonna roll this edge away from that. That should give us a little bit more clearance. We can also see right here, this most likely is another the same situation where the cardboard template and the wood template gave away. So we're gonna just kind of trace this out. We're gonna use the pipe to our advantage and trace that little thing out. Now we're gonna go to the grinder. We're gonna remove that little bit of material. We're gonna slowly work this part in here, get it in nice and flat. We'll throw a couple tack welds and then we're gonna add our gussets into the part, add that tab and slot into the part. Once it's all looking good, we'll finish welding it up. So we don't want to take too much right now. We just want to slowly work it in. We want to take our time. We had really nice laser cut parts. There's no need to ruin them being too hasty with it. So let's come back over. We'll check those 2 spots that we just worked on. Okay, so that looks great now. We have plenty of clearance there. And our part just slides right into place. right? So actually, we got it just about right first try. So we can see here that we have a little bit of clearance on the inside of the part. That has a little bit to do with the cardboard design giving and stuff, and we had a little bit of clearance issues, but no problem filling that joint up. Let's go ahead, get the welder out. We're gonna throw a couple tacks in the corners to get everything flat, then we'll start adding our gussets in and keep tacking everything else in as we go. So we're ready to tack this thing up. I did put that front support tab in here with the tab and slot. The reason why we did that is that that's the only thing that's actually inserted into this part. So as we're welding and stuff, I clamped it in there. It's not welded in yet, but it'll just be in there to hold itself in place as we start tacking this piece up. We're gonna start by just tacking up in this corner. We have a nice straight edge that's running across the top of the car here. We're gonna measure down after I tack this corner, measure from here to here and here to here to make sure that it's nice and flat. We'll throw a couple more tacks on the other side. Then we'll start adding all the gusseting. All right, so we have a nice light tack right there. That's gonna allow us to have any small adjustments, but keep this thing from falling out as we do it. So I'm gonna slide out of here. We're gonna come back on this other side. We're gonna throw a measurement right here. So we got about 9 7/8. And about 9 7/8. So we're actually ready to go. We're nice and squared up. Looks good. Let's go ahead and throw another tack in this corner, and we'll maybe try to tack one in the back. Just double checking. We got, look at everything. Everything's looking okay. Do it. Okay, I put a little bit of a heavier tack there since we actually know that this is where we want it to be. I wanted to start kind of solidifying this design into the chassis. We want it to have a little bit of flex here and there though, so that we can get those gussets into the places that they need to be. So let's start with this bent one right here. This is gonna be one of the more critical ones since that bent piece has to align here and we want it to tie into this chassis. We're gonna have to probably do a little bit of massaging. We did remove a little bit of material on that backside right here, and that gusset went up into that corner, so we're most likely gonna have to do a little bit of grinding to get that to fit in there right. The next piece that we're gonna be putting in here is this angled and bent piece. We're gonna be throwing it up in this corner here. There is gonna be a little bit of trimming to do a little bit because that wood piece that we had in here and that cardboard and stuff is always a little bit more forgiving. So what we're most likely gonna do is have to trim back and chamfer this edge. And then since we did remove a little bit of material here, we're gonna have to pull back that corner a little bit also. So let's just kind of hold it up, kind of see how it looks. You can definitely see that we have interference down along this whole edge, but the angle looks pretty close. And so we're gonna have a little bit of flexibility to get this thing a nice tight fit in this way. So let's go ahead and mark it with our Sharpie. We're gonna pull that corner back to match this little spot here. And then we're gonna flip this, let's go ahead and flip this over, and we're just gonna kind of mark this whole entire edge, just to remind ourselves that we need to go ahead and chamfer that with the grinder. So we definitely are still having a little bit of interference here. All honesty, I think that that's still a pretty good fit. I think I'm just gonna pull back this edge and just chamfer it the reverse way, just to give ourselves a little bit of room to throw a weld in there. And then let's go ahead and tack this in, and then we'll move to the next part. So we're back with the welder. We're gonna get this piece all kind of tacked in. Since that corner has got a little bit of interference, I'm gonna kind of get this piece kind of worked up in there. And then I'm gonna tack that one corner that has that interference. Nice tight fit here, so we gotta get it just right. There we go. I'm gonna tack this corner up here that has the interference first, and then we're gonna actually just roll this thing in. And so the beauty of this is that we can do a little fusion weld here, so we don't need to use any filler. There's a little tack weld. There we go. So now we should be able to roll this piece up into place just like that. And then we'll do another little fusion weld up in the corner here. Beautiful. Now we got a nice tight joint. So I'm gonna wait to put this little joint in here until we get the other gussets kind of in place, just to make sure that if we need any flexing, in order to get them into place, we have that room to do so. I'm gonna go ahead and actually add one more right here in this corner, and I'm gonna push down a little bit on this to make sure that everything's nice and tight, and then we'll move on to the next part. So now we're gonna be working on these little bit of tab and slots here. The beauty of these is that what I like to do is have that 20 or 30 thousandths stick up that we had in the initial design. That is gonna be used as like the filler material that we're gonna be doing. And then we're just gonna start on one corner. We're gonna tack each side of this, and then we can just run the bead kind of down it and work that material in. Okay, so now that they're tacked in, I feel pretty comfortable. We're just gonna work that little bit of extra material down into that part. That's gonna pretty much make that front piece and that top piece a one-piece design now. We don't need any filler wire actually. Here we go. Okay, so now that we have that front piece all in there, that's a really important time to have that brake pad or the brake pedal mounted in there. That keeps this thing nice and flat. We just did put a lot of heat into a long run on this part, so to keep it from warping and stuff. We have it tied in to about 3 or 4 different places. We have this keeping it flat, so we should be pretty safe to proceed with some longer welds at this point. So that's it. I'm super happy with how the design turned out. The brake pedal's in, everything looks great. That's how I go from cardboard to CAD to SendCutSend all the way to a finished part. As you can see, I have a lot more to do with this truck. So if you like these videos, please stay tuned for more.